Bismillahirrahmanirrahim. Assalamu alaikum. My name is Kiran Aslam. My department is chemistry and my ID is 005. Today my presentation topic is solubility equilibria of ionic compounds. First, I want to tell you presentation layout which I am going to tell you today. First, I will tell you about precipitation and dissolution. Then we will talk about saturated and unsaturated solution, classification of ionic compounds by solubility and dissolving a salt. Then we will see what is solubility equilibria and principle of solubility equilibria. And then I will tell you how we calculate KSP, which is solubility product, and how to calculate solubility. So first, what is precipitation? The formation of a solid from solution is known as precipitation. As we can see from this figure, when we dissolve solute into a solvent, the precipitate formed. So this phenomena is known as precipitation and it is a reverse process of dissolution. What is dissolution? Dissolution is a process in which a substance completely dissolves into the solvent. So it is a reverse process of precipitation and in this process we obtain a clear solution. Importance of precipitation. With the help of precipitation we can remove impurities because the crystals are formed. Scales that forms on bilates and teeth are to be prevented as a kidney stones. Precipitation forms minerals, dissolution removes them, so you obtain a clear solution. Next are saturated and unsaturated solutions. Saturated solution is one in which a dissolution and precipitation equilibrium exists between a solid and dissolved form. For example, in this figure, when we dissolve solute in the solvent, the solute doesn't dissolve completely. It will form precipitate and a time reaches when the rate of the precipitation will be equal to the rate of dissolution. So this type of equilibrium is dynamic and the rate of dissolution is equal to the rate of precipitation. The next is unsaturated solution, in which the concentration of dissolved is not sufficient to cause precipitation. For example, in this figure we can see when we dissolve the solute into solvent, the solute will be completely dissolved. So we will obtain a clear solution. This type of equilibrium is subjected to the law of mass action and equilibrium expression can be written and deductions made concerning the concentration of various species. Next is the classification of ionic compounds by solubility. There are basically three types of ionic compounds on the basis of their solubility. The first is soluble ionic compounds, which have solubilities in excess of 10 gram per liter. And the next is insoluble ionic compounds. They have solubilities in excess less than 0.1 gram per liter. And the last one is lightly soluble compounds. They have solubilities between 0.1 and 10 gram per liter. Dissolving a salt. A salt is usually an ionic compound. Usually a metal cation is bonded to a non-metal anion. It is ionic compound. It means that when we dissolve salt into a water, it dissociates into its ions. The dissolving of a salt is an example of equilibrium. The cations and anions are attached to each other in a salt. They are also attracted to water molecules. So salt is initially put into the water and begins dissolving. At first, the only process occurs is the dissolution of salt. However, soon the ions floating in the water begin to collide with the salt crystals and will pull back into the salt. So this phenomenon is known as precipitation. Eventually, the rate of dissolution is equal to the rate of precipitation. The solution is no saturated, it has reached equilibrium. What is solubility equilibria? In a saturated solution, there is no change in the amount of solid precipitate at the bottom of the beaker, and the concentration of the solution is constant. The rate at which a salt is dissolving into solution is equal to the rate of precipitation. So we say dissociation is equal to the precipitation. Nature of ionic equilibrium. Most salts dissociate into ions. When they dissolve, equilibrium then exists between a solid salt and its equated ions. For example, we can see from this equation. The lead sulfate dissociate into ions, and the equilibrium exists between its solid form and its equated ion, not between a solid and a dissolved form of salt. Many biological and environmental processes involve the dissolution and precipitation of sparingly soluble ionic compounds. For example, tooth decay. Tooth decay begins when tooth enamel composed of the mineral hydroxyapatite dissolves on reaction with organic acid. It is produced by the bacterial decomposition of foods which are rich in sugar. The next is kidney stone. Kidney stone formed when moderately insoluble calcium salts such as calcium oxalate precipitate slowly over a long period of time. Next is the principle of solubility equilibria. Let's consider the solubility equilibrium in a saturated solution of calcium fluoride in contact with an excess of solid calcium fluoride. Like most sparingly soluble ionic solutes, calcium fluoride is strong electrolyte, so it will dissociate it with hydrate ions, calcium and fluoride. At the equilibrium state, the ion concentrations remain constant because the rate at which a solid calcium fluoride dissociates to these calcium and fluoride ions will be equal to the rate at which the ion crystallizes again to form calcium fluoride. The equilibrium equation for the dissolution reaction will be Ksp is equal to the concentration of the calcium and fluoride ion. Where the equilibrium constant is called the solubility product, I would simply say the solubility product. For the general solubility equilibrium, the equation is this. Remember, the concentration of a pure solid or a pure liquid is omitted from the equilibrium because the ratio of its actual concentration to its concentration in thermodynamic standard state is equal. The equilibrium constant expression for Ksp is equal to the rate of is equal to the concentration of the products. Ksp always equal the product of the equilibrium concentration of all the ions on the right side of the equation with the concentration of each raised to their power of its coefficient in the balanced equation. Here I added a worked example for the calculation of solubility product. For example, if we have to write the equilibrium constant expression for the solubility product of silver chromate, first we will write its balanced chemical equation. Then the exponent in the equilibrium constant expression for solubility product are the coefficients in the balanced equation. Therefore, we will arrange this equation as, and this is the solubility product of silver chromate. Write the dissociation equation first, write the solubility product expression, leaving the reactant concentration. Here is an example to calculate the solubility product. Lead chloride is dissolved to a slight extent in water according to this equation. So we have to calculate its solubility product if the concentration of the lead is given. Because here is 1 mole of lead and 2 mole of chloride ion. So we will multiply the concentration of lead with the chloride. We will obtain the concentration of chloride ion. Considering the equation, if lead concentration is x, then the chloride concentration is 2x. So by putting the value of the concentration of lead in chloride, we will obtain the value of solubility product. Right, this is how to calculate solubility. For calculation of solubility, write the dissociation equation first. Use the equation to calculate the amount of ions given that S of the solid dissociates. Write solubility product expression and substitute the S value and solve. For example, in a saturated solution of silver carbonate, what is the molar solubility of the salt and if the solubility product is given? First, we will write a balanced equation because the ion of silver is 2, so we will write 2s and the carbonate ion is 1, so we will write only s. And after multiplying 2s into s, we will obtain 4x3 These are the power. So we know the solubility product is equal to this. So we'll keep both of these equal and we will substitute the value of S. And we will obtain the solubility value of the silver chromate. So this is how we calculate the solubility of ionic compounds. So that's all from my side. Thank you.